Hello everybody, this is Mr. Longo and I'm back to talk to you about the Pythagorean identity. Now you have to remember that the Pythagorean theorem is a squared plus b squared is equal to c squared. But the Pythagorean identity is in terms of trigonometry. So that is sine squared plus cosine squared is equal to 1. Okay? And we did a little bit of that with coordinate trig, and when we are working with the Pythagorean theorem, this is a little bit different because you're given the ratio of a given trig function. It's going to be sine or cosine. So to do this, it's really not that difficult. It does require a calculator and some calculator skills. So let's just hop to it so you can see what's done, and it's really not that bad. So the first thing you want to do is think about what quadrants our answers are going to be in. So we are given that the cosine of theta is equal to 0.5437. And you should recognize the fact that cosine is positive. So cosine is positive when x is positive. So we're going to be in one of those two quadrants. Now we're just going to use the Pythagorean identity. So we are given cosine squared, so we have sine squared theta plus our given cosine, which is 0.5437 squared, is equal to 1. Now we're going to have a whole bunch of fancy decimals here. So this is where the calculator comes into play, and you could type this in the calculator and get a decimal and then subtract that from 1, or we can do it a much easier way. We can just understand the fact that we're about to subtract whatever this value is from 1. So I'm just going to type 1 minus, and then we have 0.5437 squared. And after we do that, we are going to get a long, crazy decimal. Now, again, do we want to write that all out? Sure, if you want to. However, what we have to do now is take the square root of that value. So, to do that, all you have to do is second square root, and then you can press second negative sign, which is going to say, take the square root of the previous answer, please, calculator. Click enter, and we get 0.8393. So again, you can show all of your work with those nasty decimals if you want to. It would look a little something along the lines of sine squared theta plus 0.29 ... is equal to 1. You would subtract that 0.29 crazy to the other side, and you would have sine squared theta is equal to 0.7043 ... Then we would square root both sides. But the calculator is much easier to do, and when you're done, you end up with the sine of theta is equal to plus or minus your 0.8393. Now remember, the plus or minus comes from the fact that whenever we take the square root when we're solving, we have a plus or minus. And that's going to tell you which quadrant each one of these is in. So, this is where you have to be careful how you write your answer. The sine of theta is equal to a positive 8393 in quadrant 1. But it's equal to a negative 0.8393 when we are in quadrant 4. Okay, so you have to be specific to each one. Don't just write sine is equal to plus or minus 0.8393 in quadrants 1 and 4. You must be specific to which one is in which location. Okay, but that's basically it. That's all you really have to be able to do. So there are 3 more examples here, and most of them are just done exactly like that in the calculator. The important thing that you have to remember is that you are making sure that you're choosing the correct quadrants. Okay? Oh, and a little side note, if you did not get any of those answers in the previous problem, make sure you press mode and make sure that you are in degrees. Okay? That would be very helpful for you. So just make sure you're in degrees if you got anything kind of different. Okay? So let's go back out and, like I said, pause the video and give the rest of these a try. Okay, so for number 2, the first thing you were given was a positive sign. So you should have had your train of thought telling you that we're going to be in quadrants 1 or 2, because that's where y is positive. And then, of course, you would need to set up your equation. So it would be 0.4828 squared plus cosine squared theta is equal to 1. And this is where you would use your calculator, and you would come up with the cosine of theta is equal to plus or minus 0.8757. And this is where you had to go back and think about what location you were going to be in. So cosine is negative in quadrant 2, positive in quadrant 1. So we should have said that the cosine of theta is equal to 0.8757 in quadrant 1 and equal to a negative 0.8757 in quadrant 2. Okay? For the example after that, again, we are given cosine, but this time we are given that cosine is negative. So we're going to be starting out in quadrants 2 and 3. But again, after that, you should have had the exact same setup. So we should have, once again, sine squared theta plus our given negative 0.3421 squared is equal to 1. Type in the calculator 1 minus the 0.3421 squared. Take the square root of that decimal value, and you would end up with sine of theta is equal to plus or minus, I'm just going to separate it right now, plus or minus a 0.9397. Now let's state what quadrant we're supposed to be in. So we have a sine value is positive when y is positive. So this would be positive in quadrant 2, and sine is negative in quadrant 3. Okay? And that's that. The last example that you had, same setup, just make sure you're asking yourself where you're at. Sine is negative in quadrants 3 and 4 because that's where y is negative. And again, the setup, we have a negative 0.1721 squared plus cosine squared theta equals 1. 1 minus negative 0.1721 squared is going to give you cosine squared. Take the square root of that value, and you're going to end up with the cosine of theta is equal to plus or minus 0.9851. And then last step, what quadrant? Cosine is positive in quadrant 4 because that's where x is positive. And our negative cosine is when x is negative in quadrant 3. Okay, so that's why it's very helpful to draw out this little quadrant sketch at the beginning. Okay, but otherwise, like I said, like the first example where we did step by step using the calculator, just make sure you know how to do that and you're good to go. All right, this is Longo and I'm out. See you, bye.